share our screen. Oh, they're gonna see our work. They're gonna see all this work that we've done.
Big sprint in the last 48 hours. I know. I'm pumped. Thanks.
Oh, good. All right, it's out there. It's out there. We're committed. All right, that's my slide. Good stuff. You made it. Welcome. You know, this is intense. So we've got very little time. So let's get this out of the way. He's Matt. I'm Josh. You work at Okta, right?
I do.
What do you?
My dad calls it okra.
Right, delicious. I like okra. Who doesn't? Oh, so
tasty.
Yeah, and me, I work on the Spring team at VMware. We sell virtual machines, and I don't know. We have got a Kubernetes thing, so that's nice. And you know, Spring. We work on a lot of open source. Oh my goodness, so much open source. Just like Okta, actually. You know, a lot of good stuff there too. So, yeah, we Matt here, and he said, "Hey, you want to do something stupid?" I'm like, "Yeah, always, anytime. Let's do this." And so he said, "Let's do a presentation together for the San Francisco Java user group. But don't worry, we're going to do something like we're going to talk about what was the talk?
Spring Native."
Yeah, I'm like, that's a terrible idea because it requires lots of builds, and the builds are excruciatingly long, and then somehow here we are.
Right. And so you might think of it like, have those guys been hacking for 48 hours? And really, we've only hacked for about
36.
3 hours.
3 hours. Oh, yeah.
And we've been waiting like
cycle time is just
15 minutes between each hack.
Yeah. So we're hoping to spare you some of that cycle time, that nonsense. So let's talk about Growl, right? Like the goal here right now, as we stand before you, the goal here is to talk about how to build applications that take advantage of Growl VM. Now, Growl VM is a ahead-of-time compiler. It's an ahead-of-time compiler that was developed by Oracle Labs. The goal of that ahead-of-time compiler is to ruin your day, to absolutely just end all hope and productivity for that day. And the other goal for that ahead-of-time compiler is to take what we already knew, what we already appreciated was possible with the just-in-time compiler that's been in Java since forever, like 1.2 or something like that.
Right.
It's to take that just-in-time compiler and which has as its core conceit the ability to take your bytecode, right, your compiled bytecode, and to turn that into native code, just certain parts of it, certain paths in the code. And one of the things that's so amazing about this is that for certain workloads, for certain classes of applications, a Java application, remember, Java is formally an interpreted language, Java application with the just-in-time compiler can actually perform better than similarly written C++ and C programs, because at some points, because the just-in-time compiler has a whole world perspective on your code, it can actually see optimizations that you wouldn't be able to see or wouldn't be able to do in a non-memory managed controlled language like C or C++. So Java has a wonderful reputation for being fast. And that's in large part to the just-in-time compiler.
So why do you need Spring Native then?
Well, a couple things. First of all, Growl VM originally started off as a just-in-time compiler written in Java, right?
Right.
I don't know if you've ever looked at Hotspot, but it kind of got more famous. I mean, if you're in the Java community, you know about Hotspot. It's been there, but it became a core issue in the Oracle Google Android lawsuit, right? There are actually expert testimony from Java experts talking about Hotspot of all things, you know, because that was actually a very big deal in one of the things that distinguishes Java from so many other platforms and runtimes. And so they had this thing called Hotspot. It's spaghetti code. Of course it is. Why wouldn't it be? It's an incredible piece of architecture. It's an incredible piece of code. It's been there for decades. It's a miracle that, you know, it works as well as it does. But the goal was originally to sort of rewrite that, to take advantage of Java and write the just-in-time compiler for Java in Java, right, as much as possible. And they did a great job. It's clean. It's fast. You can use Growl VM as just an OpenJDK C2 garbage, you know, just-in-time compiler replacement, and that in of itself is very, very fast, right? There's a lot of benefits to that over just plain vanilla OpenJDK.
And it installs Node for you.
Yeah, which is, you know, if you want that, yeah, sign me up.
So just be aware of that, because like you have a Node instance, you install the Growl VM JDK, your Node instance is no longer the one so I've learned that. Watch out.
It's a no to take away my node, you know.
Right.
So it's a node no.
Node no.
Yeah.
To use Growl VM.
Yeah. So that's a thing. And anyway, the Growl VM, the just-in-time compiler is awesome, but at some point they said, well, wouldn't it be great if we appreciate what Growl VM is doing as a just-in-time compiler, wouldn't it be great if we could just, what if all of our code was like native? Why just certain hot paths, right?
Right.
And by the way, that hot path thing, that's really, it's amazing, right? Because large organizations like Google and Alibaba, they know of this mechanism, and they know that it takes some warm-up time, right?
Oh yeah.
Only certain parts of your code, after they've been successfully accessed, get converted into this native path, right? This native code. And only under certain scenarios that depend on the phase of the moon and reachability of the objects and all that kind of stuff, right? So they know about that. They warm up, they proactively deploy services and throw a ton of load at them to get them to get warmed up, so that by the time they actually go live in front of the world, they're native, you know? So a lot of organizations have been clamoring for this, right? And so here comes GraalVM, and GraalVM has, it has this native image component. So if you want to use what we're going to talk about today, first of all, you need GraalVM, which you can do if you're on a Mac. There's something called SDK Man, which is cool. It stands for manager, not man, you know. And it's a manager that you can use to install different JDK components, including GraalVM. And then you do gu space install space native -image, and then you're ready to go. Now, GraalVM, in order for this native image compiler to do its work, this is a separate thing from the Java compiler things in the package, right? So in order for it to do its thing, it does a whole world analysis of your code base, and it throws away everything that it cannot see at compile time, right? Java, wonderful though it is, stodgy old language that it is though, because it certainly feels a bit more, it feels to me, when I write Java code, it feels more like C and C++ than it does Python and Lua and JavaScript and whatever.
Sure. But
it's actually got a lot more in common with Python and Lua and JavaScript and whatever. It's actually, in terms of its runtime, in terms of its capabilities, that's not C and C++ or COBOL or whatever. It's way more. You can eval things basically, right? I can write a string. I can turn that string into a class, a definition through ASM. I can register the class in the class loader. I can dynamically instantiate an instance of that class with reflection. And again, never having a statically type reference anywhere in this whole chain. I can invoke methods on that type. I can create JDK proxies with that type. And again, never have a reference to a type. I can just do it all through strings and magic reflection, right?
Right.
So the JDK is, and I can then serialize that type. I can take those bytes that I just created from whole cloth from a string, and then write them to a disk, and then load them in another machine, and the cycle continues, right?
Yeah.
So it's a really, really dynamic runtime. And so this static compiler, this native compiler, it wants to throw away everything it can't see at compile time. But of course, for the reasons I just told you about, there's a lot it can't see at compile time these are not bad things, they're just things it can't see, right? And so what we have to do is we have to make sure it sees it. Otherwise, it's going to chuck all your hopes and dreams and ambitions out with the garbage, right? It's going to just throw it all away every time it runs the compiler. And that's a bit of a problem because, again, Java is very dynamic. So enter Spring Native, all right? Spring Native is this project that is designed to provide the hints. We call them hints. These are little clues that feed into the native image compilation process that tell the GraalVM compiler about all the dynamic things that a typical Java application will do, one written in terms of Spring and Spring Boot in particular. And this is a big problem because, of course, Spring isn't just Spring. It's not. We don't reinvent, everything. We reinvent the things that we feel like we can make a difference. But one of the best parts of Spring is that it integrates this massive ecosystem.
Right.
So our ambitious goal is to make native compilation available to all Spring apps, and that includes its ecosystem, right? And so that's a big thing. So we needed a component model that supports that. We needed it to be easy to use. It has to be minimally invasive, and it has to be extendable. It can't just be like that it comes from on high and that's the only way to get changes. It has to be something that other library developers can use. So with that foundation set, I think we should do some demos and get into it.
See some code.
Okay, so let's do the happy path here. Let's do like normal case sort of scenarios here. Woo. Okay. Good stuff. So we're gonna build a new application. Let's see. Okay. Oh yeah. We're gonna build a new application as always by going to my second favorite place on the internet. My first favorite, obviously, is production. And by the way, this is a big feature that's designed for production, right? This is an architecture discussion.
Oh, it's serverless.
For the win.
Yeah,
for the win. It's JR Elite. When you use GraalVM what you get is a binary that is architecture specific. So it's Mac OS or Linux or Windows specific.
Right.
And it doesn't have a JRE.
Right.
And it starts up in very, very little amount of time, very, very quickly. And it takes a minimal amount of RAM. So this is an ideal choice for people who want to take applications that aren't just fast, but also minimally, that have a minimal footprint, a memory footprint. In the world of, Kubernetes and cloud native services, the better bin packer wins, right? That's the more services I can deploy into the same cluster, the happier I am, the more value I'm getting out of that cluster.
Right.
So, this is a big deal. We want that kind of stuff. So I'm going to go here. I'm going to build just a simple application, basics. Let's say traditional, okay? And I'm going to bring in Spring Native, which is, by the by, experimental. It's not GA. It's not finished yet. It's still early days yet. It's not final. And if you saw our recent Seminole Spring One conference just earlier this month in September of 2021, we announced that our intent is to make this native support, to bring that into Spring Framework 6, which is due next year, and Spring Boot 3. So the next generation of both of these sort of key generations will have native support for native support, right? But that's a lot of that.
So will this go away eventually? Is that like something?
I have no idea. This is the thing. Like, I know we're incubating a lot of this cool stuff right now, right? I don't know if it means that this goes away or if it means we release a thing in between. I don't know. It's certainly, it's workable, right? As you've seen,
we made it work.
You can do some pretty amazing things. Some less elegant than others, mind you, because again, GraalVM is anathema to what Java is doing, right? Just the Java ecosystem is bigger than what GraalVM wants to do. So there's a lot of work sometimes,
right? As
Matt and I found out, and we're not the working types. So you can imagine our displeasure. Now we're going to build an application here. We're going to use the we're going to use the Spring Native support. What are we going to do? This is traditional. We're going to use JPA because I make terrible life decisions. I'll use H2. I'll use the web support, and I'll hit generate. Okay. Now, I don't think GraalVM supports Java 17 yet, does it?
Well, check SDK, man.
Does it?
All right. A little SDK list Java.
Oh yeah.
And you got to like grep for GRL or something. There it is.
16.
16, right?
Yeah. So I don't know. We're going to use 11 because that's the current long-term supported version against which you can park your code. My expectation is that any minute now, like, come on, they'll release maybe it's next month or year. I don't know. I have no idea. Nobody tells me anything, especially not Oracle. But my expectation is that eventually they'll have a GraalVM native image compiler that supports Java 17, the just released, super awesome, blazing fast Java 17.
But if you look at Spring Boot, doesn't it allow you to build with Docker or with the Graal stuff? So technically you could have JDK 17 installed, build with Docker, and it wouldn't matter.
Right, because it would have used, but you couldn't use Java 17 syntax. Right, which is a bit of a bummer. Like runtime wise, of course it doesn't matter. And that's a great point. We're going to talk about that. Don't let me forget, because I didn't even have it in my head that we should show that, but that's a great thing. Okay, so my point is we're going to use Java 11. We know better. We want to use Java 17. We do. It's out of our our hands at the moment. Okay, so do I have what is my Java? Let me make sure that GraalVM. There you go. So that's GraalVM. It's that's the version I'm running right now. And I've got this zip file, and I'm going to open this up in my IDE. Just a traditional sort of imperative IO based application, just your everyday kind of use case. Nothing schmancy, nothing special about it, nothing reactive or scalable or whatever. You can't see this, but we're very well lit, so it's studio hot in here. I am melting.
Do you want me to fan you?
Fan. Can you all hear this? If we turn on
someone give this man a palm frond.
Let's see here. Is that audible?
I don't think you even hear the AC, do you?
Nope.
So,
thank goodness.
So we have this tool.
Josh, I can't believe you didn't show dark mode on start.spring.io, man. You're slipping.
You're slipping. Look at
I'm
this.
Just kidding.
Ooh.
Oh.
Is there going to be a Halloween one again?
I hope so. That was so cool last time. Oh, that's so good. Okay, so the traditional application, right? Your bread and butter kind of application for many of the last 20 plus years. Okay, so it's just going to be an application that writes to a database. got one thing. I want Lombok because I don't have Java 17. I've been doing all my demos that aren't to do with GraalVM on Java 17. And yeah, I don't need Lombok anymore. My life is great. But here we are back in Java 11 land. Still need it. Don't have records yet. I miss them. Have you tried records?
Well, I have, but you can't use them for JPA.
Yeah, but we use JPA.
I'm just saying, like, one of the whole points of records that seemed cool was like, I can use these for entities. And then they're like, oh, you can't.
Really?
Right?
That's
not. I don't know. There's something like.
Oh, the properties. Oh, it doesn't know how to do the read-only fields. Oh, that's true. Okay, well, anyway, that's a bummer. I didn't know that. It works with Spring Data, and it works with Json, and it works with
yeah, and I'm willing to bet like people will figure it out, right?
Yeah.
But it wasn't like a core feature when they added it or not.
Yeah. Oh well. Give them a minute. They're sharp, that team, the Hibernate team. They'll make it work. Okay, so customer. There's my basic entity, and I want to have a repository that writes that data to the database. So the repository extends JPA repository, managing instances of type customer, whose primary key is of type integer. And this is also going to be a generated value. All right. And then finally, I want a controller, REST API, right? So I'll build an HTTP endpoint here. And we'll say customer REST controller. All right. And git mapping, customers.
Now, why do you do controller instead of REST controller there?
Because we have now, we have RSocket support, we have GraphQL support, we have WebSocket support, we have HTTP endpoint support, and they're all controllers.
Okay.
And I just figured it's easier in my head to just remember controller, and then just add response body for the REST controller use case.
All right.
Rather than, because we don't have dedicated annotations. We could create them.
Right.
We could create meta annotation, like at GraphQL controller, at RSocket controller, at WebSocket controller. But, do you know a controller doesn't even live? I don't know if people realize this. Look, this isn't a web annotation. I bet you always thought that was a Spring MVC thing. No.
Right?
Yeah, that's actually just a general purpose core annotation. It's meant to describe something that controls the responses from outside. Huh. It's not a web MVC thing. It's a general purpose thing. So whatever, you can do REST controller. It's
right.
This is the exception that I make to remember the scheme.
So it's pretty much the same thing as REST controller.
It's exactly the same thing.
You
it's
just like to write 2 lines of code instead of 1.
Well, but then I don't have to reconcile why I've got an exception no matter what. Like it's controllers and REST controller, or it's controllers all the way and response body.
Right.
Right. So whatever. Yeah. Okay. So there's that. So I've got. I'm going to inject this. Oh, hey, come on now. Come on. Don't get weird. Let's see. Customer repository. Create a constructor the old-fashioned way. Scanning files. What are you doing? Did you see that?
It's IntelliJ still indexing. It's like, hey.
I asked it to create a constructor. It's like, no, I got to call home. Look at the time.
It's like GraalVM. It's like searching your whole project, being like, hey. Oh, wait, it's right down there.
Yeah. Okay, so this is good. So I've got my controller. It's fine. Let's see. What else do I need? Oh, data. Right. I've got an embedded database. It's going to, let me see. I want to have a file here. So
you just create like a data.sql or something?
Yeah, data.sql. I think that'll work, but doesn't Hibernate create like its own? Let me see if I can. This could get weird. Let me see. Insert into customer name values Matt. Okay. Let's just run this and see what happens.
Yeah.
I'm hoping this because Hibernate creates its own. I don't know. I have to disable something. We'll see.
Hopefully we get some conflicts with stack trace.
How dare you?
Maybe just nothing happens.
Dirty dog.
Oh, there it is. Like, nope.
Table customer not found.
That's where you need the schema. Where's your H2 saying like create the shit?
Yeah. Let's see. Schema.sql. Oops, schema. That's down. Great table.
Is that because you don't have an entity annotation or what?
Do I not have an entity annotation? Oh, I forgot about that. Okay, yeah, thanks. Thank you. That probably explains a lot. So maybe I don't need this. Let's try this one more time. Okay, let's see. Santa Maria. You can tell it's been a minute since I've done this.
I think there's also a recent Spring Boot update that turned it off by default.
For what?
For like
Really?
creating the schema, but I'm not sure.
Create table customer. I know it's, I thought it was on for embedded databases, but not for
All right.
external like Postgres or whatever. Well, okay, good. Okay. Create table. Please work. Just wanted to work so badly.
See, there you got one from Daryl there. He's like the DDL auto equals true.
Yeah. Oh, but it should be just, that should just work, right? Like it doesn't work anymore by default. I feel
angry.
Lost. Okay. Oh, okay. Now we need, wait, so the data is value. How come there's no data? Oh, did I? Yeah, that's got getters and setters, right? String. So if I went up here, customer C, yeah, it's there. So what's the deal? Data schema, schema.sql, data.sql. Oh, so that's what it is. Hibernate is creating the schema as well, I think. So
you get two schemas going.
Yeah. None. This can be very confusing. Thanks for the tip there, friend.
Well, that was me. That was our buddy here.
Yeah, that's what I'm talking about.
Yeah, Daryl Spielman.
Yeah, thanks, Daryl Spielman. I appreciate you. There we go.
There we go.
Whee! That's good stuff. Okay, so I want to take that. I want to turn that into a native application. So I'll go here, and I'm going to activate the native profile. I'll say native profile, the Maven profile here. Maven, and then clean, and then package. Right? I'm going to
no clean.
No clean. Why not?
You never do clean with Maven.
I always do it. I don't trust anything. But I'm not going to run the build.
But you didn't even combine. Well, yeah, go ahead.
No.
If Andreas Allmurray were here, he'd be like, "What are you doing?"
9. Yeah. Okay. Well. Okay. So skip tests equals true.
Yes, always skip your tests.
Always. Nobody got time for that. This is going to take long enough. And the reason it's going to take a long time to run your test is because it's actually nice enough to compile your code to compile your native code as a test. Compile your native tests or tests natively, which is cool. If you want to test how your application behaves in a native context, it'll do that, right? But that means it doubles the length of the compilation. And again, remember, it's not just compiling your Java source code. It's compiling your Java source code and all the .class files. It's taking every class file in the entire class path, deciding if it's been used or not, and then
Right, but it makes me wonder. Like, we had a lot of times this week where, like, we got it to build and then we ran it and there was an issue.
Yeah.
Like if we had actually run the test and skipped it,
so much better.
Maybe they actually showed us.
Yeah.
When we ran it.
Yeah. No, that's good. But hashtag
so, yeah, don't skip your test.
But also
it's a
do.
demo.
Yeah.
But also do, right? But we're going to show you everything, so it just works the first time.
Well, speak for yourself. I've never had a presentation where it just worked the first time. But okay, let's see. Okay, so that's up and running. That's going to take a hot minute. Let's go do a React.
What about all these logging? Can you tell me about the logging there? Yeah, the warnings here.
Oh, these are all just sadness.
I mean, we don't even have EH cache in there. Why is it talking about EH cache?
That's why. So it's trying to run these auto configurations, right? Let's actually dissect the build here. Let's take a look at that.
So is it like aware of every single auto configuration that exists?
Yeah, it's trying to decide whether these things should be used or not, right?
Okay, so these are in like Spring Framework classes or something?
Yeah, these are Spring Boot auto configurations.
Okay.
So let's talk about this. There's an Aot Maven plugin. The Aot Maven plugin is like a clearinghouse for transformations that can happen to your code before it gets fed into GraalVM.
Okay.
So the Spring Aot Maven plugin has it takes your code, and one of the things that it looks for is a text file called spring.factories. And spring.factories is part of Spring Boot, and it's a service loader that's been in Spring Framework itself since like Java 1.6, right? When they had the service loader mechanism. And we use this. So we can basically say in the framework code, when the application starts up, we can scan it. We can say, hey, what classes should be used? Well, for auto configuration in Spring Boot, we look for this line here. We look for org Spring Framework boot auto configure, enable auto configuration equals, and then we have this giant list of common delimited Java configuration classes. And so, for example, Rabbit auto configuration is just a configuration class that has certain conditions that guard whether that class will actually get activated, right? Certain tests that get run to determine whether a thing will actually appear in the application. So for example, should this rabbit messaging template be created? Well, if this condition says no, if it evaluates that there's only one rabbit template, then it'll create this. But if there's more than one rabbit template object in the application context, it'll short circuit the evaluation of that and then not bother. And there's other tests over here, like conditional on class. So we actually do bytecode weaving or manipulation to inspect whether there is a type called rabbit template.class and another one called channel.class on the class path. And if it's not there, then we don't even bother trying to instantiate that class and invoke all the methods and all that.
So this is mostly for like the developers of Spring Native to be like, hey, I want to know what's going on.
No, this is just sadness. I don't know.
But I'm saying as a developer, like you see warnings and you're like, what's going on here? Like, will these eventually be hidden is what I'm asking. Someday, maybe not.
Nobody tells me anything. I just work here, man. I just got here 11 years ago. I'm new. So these annotations are pretty useful though. Right. Like this one's particularly useful, conditional on class. Well, that makes a lot of sense in the JVM where you have stuff dormant in the class path and you might compile against one thing, but run it against a different class path, right? So you want to actually test whether what you linked against is actually there in runtime, right? Well, in GraalVM, if it's not in the compiled code, it's never going to be there.
There's no runtime.
There's no runtime, and there's definitely no class path,
Right.
Whatever's in the static native heap, that's it. That's what you get. You're stuck with that. So we can evaluate these conditional annotations ahead of time. We can look at these and evaluate them at compile time and just, rewrite or create a new Spring.NET Factories that has already, whoa.
Oh.
What did I do? Okay. We can evaluate these configurations and we can say, okay, well, this is never going to be run. There's no point. It's never going to be true. There's no point in having this. And that actually that's a transformation that we do, right? There's actually a thing down here. Where's my target directory here? Target. Okay, let me synchronize this. Sometimes the file reload from disk. Okay, good. There's the binary. Oh, good, it worked. Okay, so go to classes. This org Spring Framework, AOT, static Spring Factories. This class, we write this class at compile time with the the Maven AOT plugin. And that in turn is like a Java version of that text file with all the interesting conditions pre-evaluated, right? The conditional on class.
Right.
So now the work of winnowing down the large class path into possible things that could be true, all that is just done before the application is ever compiled. First of all, we avoid loading a text file and we avoid doing reflection as well.
Right.
This is all just static, information, right? It's all classes with other classes.
How many lines is that long? You're doing a hello world app.
Yeah.
300, not bad.
Yeah. So here's all the enable auto configuration things that evaluate to true. These are the ones that are actually going to be true at runtime that have a chance of being true.
Okay.
Right. So that's one thing that you'll see that the AOT plugin might be doing these kinds of transformations. One of the transformations that we're working on right now is, what if we could take your Java configuration classes and translate that into functional config? Right. That's another big one. So okay, good. So there's this. There's my my AOT app. Let's go see the result. Okay. So CD traditional. CD target, nope, not CC, CD, good. Traditional, or not, what happened there?
Oh, it's working.
It's slow.
Well, that's because you're on Zoom.
Oh yeah, there we go. There we go. It's about 0.191, 191 milliseconds, so 191 thousandths of a second, which is fine. It's okay. It's not great, but it is JPA. It is Tomcat. It is all the traditional stuff. And also I'm embedding H2. I'm starting up a whole SQL database that's SQL 99 compliant in memory.
And you're sharing your screen.
And I'm sharing my screen. Right. Yeah. Things are not great here, but that's okay. Right. There's reasons. So, okay, let's see. That's a traditional application. I don't like these kinds of applications these days.
You said you gave up on them.
I gave them up.
Reactive.
I gave them up for Lent. I don't need them. What's the point? So, good. So the kind of applications I will write these days using, okay, I'm going to do a reactive, okay, and then I'm going to do reactive web, R2DBC, H2 native, and Lombok. And by the way, you can use Kotlin, that works fine too. So
What about Gradle? Are you a fan or you prefer Maven?
I use Maven, but I have no reason not to use Gradle. It's just not the hill I want to die on. I don't care. Yeah.
Right.
Use whatever you want. It's fine. Who cares? As long as you get to production fast. Okay, reactive. You can also use Groovy. That's a very nice language as well. Okay, so class customer, private. You remember Howard Lewis Ship?
Oh yeah,
Love that guy.
Tapestry guy.
Yeah, he was.
What made you think of him?
Well, he used to write code. His Java code looked like C code. He'd do the C style.
Oh, he'd do the brackets on the next line.
Like that, yeah.
Oh, yeah.
And I remember reading Tapestry in action. I was like, oh, that looks so different. Yeah.
You're like, what do you do it?
It's interesting. It's just not the Java bean style.
All right.
Okay.
So we do have a question from Chris here. Is it embedded container, e.g. Tomcat, compiled native?
Yeah, everything is.
Everything.
Everything.
Right?
Yeah. Which is for better or for worse, you know? Okay, so there's my entity. Good question, by the way. Customer repository. Extends reactive CRUD repository. Customer integer. Okay. And want to data.sql. Create table. No.
We had a reactive CRUD repository and it was from R2 DBC.
Yeah.
That's pretty sweet.
Yeah. I didn't even know you taught me this just yesterday. I didn't know that we even added an R2DBC repository. So I guess I should be doing that. That's cool. That takes some
There you go.
getting used to it. Okay. What file is this? Data.sql. So insert into customer, name, values, some people in the Spring team, and the Spring ecosystem. And let's see. Olga and
That's a cool name, Violetta.
Yeah, Stefan and the good Dr. Sire. Okay, so that's 8, right? Surely. And then we want the schema. So create table, customer, ID serial, primary key, name varchar 255, not null. Nope, that wouldn't have worked. Okay, let's run this and see what we get. Drink some water.
Now this doesn't use Tomcat, right? It uses
Netty. Yeah,
Netty.
Everything's going to be more efficient here. Whoops.
Oh
I
boy.
forgot to create the controller. Makes sense. Makes sense.
I do think one of the funny things that I see happen if people just create a brand new Spring Boot app,
Right.
is they fire it up and they get a 404, right? And they're like, what's going on, right? And
Yeah.
they're like, well, you still gotta create some
Got to do something. We can't literally write the code for you.
Right.
Unless you use JHipster, in which case we can. Let's see, git. And I need to inject this thing. Oh, I miss records. How many, just by a show of hands, how many of you have already upgraded to Java 17 and are using it merrily in production? And the rest of you, why not?
So hands, there's let's see, we gotta get a new view here. Yeah, gallery view.
It's awesome. They've outdone themselves. You shouldn't be a question.
I don't see any hands.
Oh, is there a hands view?
But you put
something
an
in the chat.
icon on it, right?
Oh, is that a thing?
Yeah. If you're using Java 17, we'll send you a t-shirt. Anyone using Java 17?
I mean, I don't speak for yourself. I don't have any t-shirts.
Matt, you should send a t-shirt to the guy that gave you the setting for Spring Hibernate. If you have a
Yeah,
t-shirt.
auto, yeah. Hit me up on Twitter with your address and size, and I'll get you one.
Oh yeah.
Yeah, Daryl. It's drop that in there in the chat.
Yeah.
Okay, so we built a native image using the Maven profile, right?
Okay.
And that was pre-configured last time. We saw I didn't do anything to the POM. I showed you around a little bit, but there was nothing I did really. The Maven plugin is there. The Aot plugin's there. We configure.
But Lombok, you have to configure that as part of the Spring Boot Maven plugin. I know, but when you create it from start.spring.io,
Yeah.
that's new. I haven't seen that, right?
Yeah,
So,
it's neat. And then down here, there's this whole branch of profile where we're configuring the Gravium compiler plugin.
Right.
And the Maven plugin. I don't know. It's all this. It doesn't matter. The point is it works. But what I got was a Mac OS specific binary, right?
Right.
What I'm normally going to want is a Linux Docker image that I can deploy into my cloud,
Right.
right? So there's this thing called build packs, right? And with the build packs, whoa. So I can go here, I can say Maven clean spring boot build - image. And what that's going to do is it's going to create a Docker image out of our application. And I think, unless I need to specify the profile, I don't think I need to. So the point is,
nope.
It's going to create a Docker image out of my, it's going to create a Docker image and then compile the code in the Docker image, create a native binary. Oops, did the wrong thing here, friends. What did we say?
Because you cleaned?
No.
You didn't skip your test?
Yeah. So it's gonna create that Docker image for me,
right,
and compile the code into a native image, and then create a Linux container that has my Linux specific binary, my native binary, which is great. So then I can just Docker tag and Docker push that straight to my VMware Harbor.
Right, because I think the first question, right? The Docker daemon isn't running. Oh, you got to buy a license for Docker Desktop.
Not again. Oh, this is awkward. Oh, my operating system is so unhappy with me.
Is it not running?
I have to restart Docker. And by the way, good. That's actually a good point.
You got to upgrade.
Skip that for now. Hard pass. So when you go in here, when you do the because remember, you're doing the GraalVM compiler is like Slack. It just takes tens of gigs of RAM. It's insane, right? So make sure you allocate as much memory as possible to your Docker desktop instance. Otherwise, you'll not enjoy the.
So how much do you have?
Like 25, I think. It's probably a little overkill, but it's never barked at me that it wasn't enough, right?
And you got a 64 gig laptop.
I got a 64 gig laptop. Yeah, this is I call this the Slack machine, right?
That's your Slack machine, yeah, because it's got 64.
Yeah, that's ready. I can run Slack and Chrome and Visual Studio Code all at once. We're finally here. You know, Ultron is that robot Ultron is buried in the code for this thing somewhere. You know, like it's craziness. Okay, so you can see it's downloading.
It's got the old builder tiny, huh?
Yeah, the tiny build pack, because it doesn't need it's a statically linked self-contained binary. We don't need a JRE, and we don't need to link everything in the operating system, right?
And so it uses a different one than the default.
Yeah.
If you weren't using Spring Native.
Right.
If you were just using regular Spring, it would be a different build pack.
Yeah, like a more full-featured operating system, because it needs to be able to support the JRE and all of its complexities. Right. That is to me the crazy part, is that you get a binary that has not just the minimum that you need to run your application in your class path, but the minimum that you need from the JRE.
Right.
You don't pay for what you don't use. Well, at runtime anyway. So there's no Java, or maybe there is, but it's only if I need it, right? Like,
right. Yeah.
Or whatever. I don't know.
That's great.
So this will take another few minutes. And that's fine, right? So what we're going to talk about next is what happens if things don't go so swimmingly, right? So thus far, I've kind of like, luckily, not had so many issues, right?
It all worked. It's a miracle.
Yeah, well, the happy path, certainly, right? But let's talk about what happens when it doesn't work. And that's, as Matt and I have discovered, it's a thing.
It's a thing.
It's a thing. It's not, we're not, GraalVM, like I say, it's not yet, remember, it wasn't even GA until like a year ago, right? I don't know, recent in memory, right?
Yeah. That's
GraalVM itself. So let's go here, and we're going to call this application Hints, okay? And we're going to use Spring Native. Well, that's it. That's all we're going to use. So we're going to hit generate. UAO hints .zip. And where's my compilation? Not here. Okay, this is still going. Got to remember to check in on that in a minute. Okay, so what happens if things don't go so swimmingly, right? Remember what I told you. The core problem is that GraalVM hates your code. It just hates it so much. It wants to Marie Kondo all of it. And so every time it does a compilation, it tries to chuck everything you've worked on, all your hopes and dreams, all your ambitions, into the bin, like so much garbage. And so what you got to do is say, no, I'm keeping that. I need that one bit. And the way you do that is through something called hints. Okay. And there's actually a set of configuration files that you can provide that GraalVM supports, and it normally looks for those in the source main resources meta-inf native image, native-image directory, and then it expects another directory, and then your config files. And those config files are they're JSON, right? Which is great. I respect it.
They say aren't YAML.
Yeah, exactly. Thank you. Exactly. We're part of the hashtag no YAML movement, right?
Yeah.
Except for when we do anything in the cloud. But anyway, yeah, I'm not a big YAML fan. So I was very pleased to see that it's JSON. And there's several files. There's like reflect config to tell it about reflection. There's resource config to tell it about loading anything from a class path, like a class loader. Like
right.
if you read like a property file or a JPEG or whatever into memory from your jar, remember there's no jar. So you have to tell it. You have to tell GraalVM about it so that it can create a shim so that when you try and do class path IO, class loader IO, it doesn't just barf.
You're basically saying don't throw this away.
Well, you're also telling it to create to give me it's like Makito. You're telling it to create a mock so that when you call those methods, it doesn't just blow up.
Right.
Right.
Okay.
So it creates a shim in some cases. Same thing for reflection. When you do reflection, there's no such thing as like taking a random type and then inspecting it at runtime. You have to have it all pre-computed at compile time. And then it creates a shim and it hands you back pre-computed information that looks like it was just inspecting your type, on a lark.
Right.
But it's not, right? It's actually completely pre-computed. So there's no such thing as completely, without a priori pre-computation. And there's a bunch of these things, and you can create these JSON files and they live in that directory, and that's fine. But they are pretty stringy, right? Stringy, and if you're a library developer and you're like Netty, for example, or logging libraries or whatever, they've already started. A lot, Tomcat, Netty, all these different libraries and projects out there have started shipping these JSON files for their particular.
So do they just add like the classes that use reflection or something like that in there?
All the things that might cause issues when used in a GraalVM context, and they're commutative, additive.
Additive.
Yeah, they get contributed. Each of them contributes to the overall mass of configuration that gets fed into the GraalVM compiler. So any library can add this JSON stuff, and GraalVM will see it and pick it up and use that when it's compiling code from that jar.
Right.
Very cool, right? And more the ecosystem is now doing this, right? And we've sent pull requests to countless different libraries and projects helping with that as well. But there's still some stuff that we have to support, right?
Right.
And so we have a framework called Spring. It's a Spring native Aot library, right? And we can actually create hints ourselves. And these hints, again, these are compile time creatures. They live and die before your code ever runs.
Right.
They're there to be fed in to
create JSON.
Right. Yeah. But they're typed, so that way, if you're using the code, you can actually have types in your code instead of strings, and that way it's next to the types that use it,
right.
And it can be refactored easily.
Right? Yeah.
Right. If you change a type in your packaging or whatever.
Right.
So I'm going to show you some of those hints, and you can actually pre-flight a lot of this stuff. Let's say I want to do Maven Spring Aot run, I think, something like that. Or is it build maybe?
Generate.
Thank you. Nope, not generate. It's yeah. Okay. Oh, okay. Gotta do package.
Oh, you can't get away from that clean.
I won't do it. It's just
it's built into your
Schrodinger's build, man. I don't trust anything. I'm still scarred from Ant,
right. And Maven 1. Right?
Maven 1, yeah, it was a nightmare. Now, for those of you not paying attention, Maven 2 came out in like 2005 or something. So
yeah,
I really should just move on, but I can't. I'm not gonna. Okay, so reload from the file system. Reload the disk. Target. Oh, it's so much stuff in here. See, why would you trust that forest of stuff? Like, I don't trust any of that. I just
clean it.
It's a landmine. Okay, so what did we do? I told you about the Aot springs, the static spring factories, and you can see it even gives you an example of what the configuration will be given the types on the class path and given all the stuff that you've told it about, right? So you can see if I want to do serialization, it's going to create a file called serialization config. If I want to load a file, I have to tell it, or a resource. And by the way, if you load a class dynamically using reflection, like class.forName, that's actually reading files. That's reading bytes from something. So you have to list the resource in resource config as well as reflect config, right? Yeah. And that gets weird, right? Look at this.
Right.
See, you have to say Java // These are directories.
Right. You're like, what the?
Yeah. Reflect, here's the actual types that get used. And sometimes you see that there are inner types,
right, with a $sign.
Yeah, there it is. Great, exactly. There's a good example. So all these things exist here, and that's pretty useful. But again, I don't want to write all that myself. So let's suppose I had a type that I wanted to reflect on. Okay.
Okay.
Well, I can use type hint. Yeah, type hint. And I can say types. And by the way, if you're using Spring and you're using Spring's Java configuration and Spring's basic lifecycle and all that stuff, that's going to work. You don't need to worry about that. What I'm talking about is if you're doing something where Spring doesn't know that you're doing.
What if I'm using XML to configure everything?
I have no idea. I don't even know. And by the way, this doesn't work with, obviously, I know this is obvious, but you can't deploy the native image to Tomcat.
Right.
Yeah. There's no such thing as like a GraalVM war or something, right? It doesn't work. It's just, but yeah, I have no idea. So yeah, types. This is only for things that are outside of Spring's purview, right? If it's not going to, if you're off on the side, you've got some, like we ran into liquid-based earlier.
Mm-hmm.
We'll actually reflectively new up an object. It'll do class type for name and then get constructors and new instance and all that stuff.
Right.
So that's outside of what Spring can see. It's not happening in the Spring code. It's not a bean or anything like that. So we had to register a type hint and we pointed it to a type, and we can do it as a string, a.b.c, or, you can do types, right? And that is, and this is an array. I'm using just a single value here, but in Java you can do,
right?
Okay, so there's a type hint, right? Okay, what if I wanted to reflect on this? Like this, I need to say I want access to everything. I want the full structure. So I can say access bits dot alt, right? As opposed to just class data or declared constructors or whatever, right?
Oh, good old JNI.
JNI, oh yeah, that's fun. Give me some whiskey and some JNI. So there's that, right? Okay, what about serialization, right? Okay, well, if I wanted to serialize this type, right? C.class, same thing. Okay, what if I wanted to load a file? And by the way, this file, this resource hint, this is the thing that's so tricky about GraalVM is that it's really smart. GraalVM is super smart. Okay, if I did, well, first of all, if you have a file in source main resources, don't worry about it. It'll be loaded already. Okay, Spring Boots and Spring Native will automatically put that hint there for you. So that's not even an issue. But let's say you had a resource in another file, in another jar on the class path. So you have like a, banner.txt or something like that, right? Mm-hmm. In some other jar.
Right.
So it's in the class, it's in the root of the jar. So if I did var resource equals new class path resource, no, not class, path resource, whatever, like that's whatever that is. Okay, I have no idea. Okay, that will actually probably still work, right? I don't know why, but at some point, GraalVM is smart enough to see that you're passing in a string. That string goes to this constructor. That constructor then gets used to create a class. I get a path and a class loader, and that it can figure out that eventually that's going to get passed.
Was that GraalVM or Spring Native? That
GraalVM.
It's the one that's
GraalVM is amazing, right? And so if you, I don't know, right? If you just create an input stream and you point it to a resource, and it'll see that that's a string. So I've actually had to do weird stuff to break it just to prove that it works. I can't show that the hint is working unless I show that it doesn't work without it, right? So I had to figure out how to break it. And what I ended up having to do is, like, if I do, I have to do like something like this. Part one, let's say it was sa.properties, and then var part two equals that, right? You have to really.
That's the only way it won't find is if you construct a string or something.
Yeah, you have to introduce some entropy or whatever. So it's really smart. So my point is, it might actually work, and you might not even need to do this. And you'll be like, well, Josh just sold me a load of goods. I had to do all that extra typing for no reason. And
so don't create the type hints if you don't have to, basically.
But in this case, it's better to be sure than, because it might not work, and then you'll waste a long time, right? Those builds are slow.
Yeah.
Oh, wait, did the other one finish?
I think so. It's down there, yeah.
Okay, so here's my Docker image. Docker run. P is to publish the port 8080. Okay, good. Oops, so it
0.1.
Yeah, 103 milliseconds. Customers. Okay, so good. So that's working too, right?
Nice.
And again, embedded database, all that.
What
right?
about your UTF-8 there?
Yeah, I don't know. I think that's like I don't know. I should figure that out. Okay. Anywho. And that's actually a Linux container, so I can Docker tag and Docker push that and deploy that straight to my cluster. That's ready, even though I built it on my Mac.
Right.
So we don't have I don't like in Go. With Go, you can actually do cross compilation. The Go programming language, you can do cross compilation on the same Mac. You can
Oh, really?
Linux
You can create a, really?
yeah, which I always liked. So you can kind of get that thanks to build
there with Docker, right?
Yeah. Okay, so that's a resource hint, right? You give it a pattern, and if it's an internationalization bundle, you have to say is bundle.
Why did you have to do that?
I don't know. And it doesn't come up very often. What other one do you need? What other hints do you have?
What about if you want to access HTTP?
Oh, yeah. So okay, if you want to access certain things, you need to specify options. There's a lot of options that get fed into enable protocol?
Yeah, enable protocol URL, or there's also enable -HTTP or HTTPS,
yeah.
right? Those are both options.
Where's the one? We'll see. He'll see it in this. Oh, it's enable HTTPS. That's what it is. So enable HTTP, and then I don't know why, but this is a protocol that isn't enabled by default. So there you go. Enable HTTPS. Yep. Right? Yep. HTTP isn't enabled by default. Not just HTTPS. I can kind of get as HTTPS, but you have to actually tell GraalVM, hey, I want to do HTTP. It's going to be a thing I'm going to do. So, do that. Okay. And by the way, notice that this is the native hint. Native hint is kind of like an umbrella type. You can actually nest. There's a great deal of nestability here. So I can take a native hint and I can say that this native hint is only active if reactive, auto, whatever, if that type is active. So if this auto configuration evaluates to true, then and only then will all the options here evaluate to true. And then I can even have other hints, like I can say resources, and I can put this in here like that. And I can, what serialization, right? Serializables. So all this stuff could be based on that top level trigger. This is a great way of grouping stuff, right? And you can see you can support everything here, right? Yep. Okay. So what else? We've got type hint. I can do types, etc. Okay. Now, okay. Another thing. This I don't need the trigger because I want them to always evaluate. What about proxies, right? Proxies are not something that you're going to probably do very often in your own user code, but it happens, right? A proxy is a design pattern. The idea behind the design pattern is that you want to create a object that has a facade, it has an API, it has a client interface that you can work with that's actually manipulating another resource, right? So a common example of this is like RMI, right? You have a Java object, it looks like a local Java object, but when you invoke methods, it's actually calling network protocols. It's actually sending messages over the network to invoke another service elsewhere, right? Okay. Another example is the Spring Data repository abstraction, right? You have the interface that looks like just an interface, right? Right. But there's nothing. Yeah. But then we get a proxy that has it's an implementation of that interface and it works, right? It knows about your types and all that, so it can persist them. So the facade is a very useful pattern. You'll see it all over the place in Java, just in general. It's a nice pattern. There's two different ways to do proxies these days. One is to use the Jdk Invocation Handler Api, so Java Reflect Invocation Handler, and you can say I want to get a proxy given an interface. So basically, you say to this API, here's an interface, give me a callback. It's like you can actually add an event listener so that when somebody tries to take that object that's been returned to them and then invoke methods on it, they downcast to a particular type and they invoke methods on that type, you'll get a callback where you get involved. Your callback code gets a chance to respond to the method invocation, right? So that's pretty cool. So now that's how you can create your own JDK proxies. It happens a lot. It's a very useful pattern, but it only works for interfaces. That's in the JDK though. So if you want to do a JDK proxy for some reason that isn't already here, you have JDK proxies, right? And JDK proxy hint and type whatever, okay? And you'll see actually Spring Native is pretty good about printing out like, hey, you tried to use this proxy. It consists of interface A, B, and C, and it'll say you need to add this JDK proxy hint A, B, and C. And by the way, you need to do it in that order, right? Right. It'll show you 3 interfaces or 2 interfaces or whatever. You need to add all of them exactly in the same order as you see it there because it matters. Okay. Right. Okay. Same thing so the other thing is, well, what if I want to use a concrete class, right? Like a class with no interface, and I want to respond. I want to have the ability to add a listener to the invocations of methods on that concrete class, right? And this is great. You see this kind of thing all the time, like transaction demarcation, right? Whatever. So that would require Aot proxies, right? Aot proxy hints. And this is a Spring specific thing. So you're even less likely to know or care about this, but it's a thing that you might do. If you do it, especially as a library developer, you should know to add this. Okay, so these are the hints. You can do a lot just with this, right? You can actually do this and just put it in your code and you're done. That you can get your application to go.
But then how do you take this hint and add it to an application that needs it?
Right, you want to reuse it, right?
Right.
Yeah, that's the next trick. So the next thing is you can actually extract out your own hints into another library. So let's do that here quickly. I'm going as fast as I can, my friend. Sorry about this. Hints, reusable hints, native, extract. Ooh. Okay, CD downloads, UAO, reusable hints. All right, so it's going to open that up.
Yep.
And we're just going to gut the pom.xml because remember, we're not creating a build here. We're just creating a regular library. Come on.
You're making a jar, not war.
Yes. Yes. Well played, sir. Well played. Okay, so we don't need any of this stuff, right? It's just profiles. Goodbye.
She's not going to native build this. It's just a regular Java project, right? With some annotations in it.
Yeah. Just compiling a jar. Yeah. Beg your pardon. Please hold.
I think he killed a spider. I'm not quite sure, but
I'm queuing up some hold music. I'm queuing up some hold music, Matt, for the next time.
So, ew. Okay, so bug guts. Okay, so I don't need this plugin here either. Goodbye. All right, so there's just a regular thing, and then I want the I need the Spring Native AOT, I think, something like that. So, Spring AOT, is that it?
Yep.
Maybe.
Yeah.
Maven.
Yeah.
Come on, Maven. Okay, good. So this is not a Spring Boot application.
Oh, so we got a good question for you.
Yes.
Is Spring Native for Greenfield Spring Boot projects only? If my manager tells me to migrate my 4-year-old Spring Boot app to Spring Native, should I say an enthusiastic yes or just walk away?
Oh, our goal is to make it so that you can take every Spring Boot application that's ever been written, upgrade it to the current versions of Spring Boot in Java, and use Spring Native and get that application working.
But there is an upgrade thing in there. Like it can't take your Spring 0.4 app and be
right. Yeah,
right.
But the goal, we want that. We want traditional workloads because again, Spring has been around for 2 decades. Right now, in 2 decades, it's a long footprint. Imagine being able to take these applications that were written yesteryear and then get them working. That's why the first thing I showed you was Tomcat and JPA and all that kind of stuff, right?
And that's why you should always upgrade too, because security, right?
Oh yeah, and you can take advantage of the new stuff, right?
Yeah.
So our intent is that yes, you can do that, but as we're going to see in a minute when Matt here walks us through some of the possibilities, it's not yet as easy as it could be. So you might have some fun,
right?
Josh, what's the minimum native Spring Boot version what's the minimum Spring Boot version that you need to be able to use it?
I think that, they're tied to specific Spring Boot versions, right? So I think like 10.4 that just came out, 0.10.4 from Spring Native is like tied to Spring Boot 2.5.5, right? And
check.
So
okay.
That's how it kind of
works. I see. Cool.
Great question. And great answer, because I didn't know either. Okay, so let's say I want to have hints. I can create a class in another jar, and I can add those hints. I can do all those same hints that we had here. Not here. Where's my hints file? I can take these hints as they are, place them there, and then just create a file here called what is it called? Source main resources meta inf services. Is it? No, it's named after the files. It's named after the type. So this type, copy, reference, and we create this new file here. Yeah, I'm going to create a file that's named after the class. This isn't the Spring.Factories thing. And then I'm going to take this full reference here and add that to this. So that's it. That's actually the Java 6 service loader, right?
Okay.
Is it services? That's my question. Hold, please. Source main meta inf services. Yeah. Okay, so direct services. Okay. Good. So, okay. And then you can just add this to, and we'll see that you can add this to the class path of your Graalvm compilation plugin. So it's not the class path of your application. It won't be seen. It has to be seen when you're compiling the code, which happens at a different phase. So it has to be a dependency on the Maven plugin, the Aot Maven plugin, not your general purpose build, right? We'll talk about that in a second. Okay, so let's say I can do hints like this. This is one thing. I don't know. Let's keep that one hint to see it work. Okay, that one's easy enough. Okay, but I can also programmatically register hints here now. So I have this interface, this callback interface, right? And this interface gives me two methods, and is valid. You can just say true or whatever. It's like this tells you when you're going to get involved, when your type system, when your hints should be involved. So I can say, hey, can I resolve this class called A, B, C, right? If it's true, then I want this to be involved, but I'm just going to say true because hashtag YOLO.
So it's kind of like unconditional.
Yeah.
In a sense.
Compile time though.
Right.
And then you have this job to return a list of hints. Right. So new array list of hint declaration. And I say a list of hints that add new Jdk proxy hint. Okay.
I totally thought you'd use list of there since you call it list of hints.
Oh, I should have. I'm a bad person. Actually, I can just thank you, buddy. Good. So var HD, new hint declaration, HD, and HD dot add. So if I want to do proxy, reflection, I add dependent type, right? So I can just add A.B.C, that kind of thing. And I can say access descriptor.
Always all.
Yeah. So access bits dot all, right? That's one example.
Yeah.
I can do add JUnit types. I can add resource descriptors. So a new resource descriptor. And this is basically the same as you see in the annotation up there, right?
Okay.
Is it a bundle?
Always.
I don't know.
Maybe that's for like internationalization, right? Picks up more than one. You don't have to specify all of them.
Oh yeah, exactly.
I think the bundle probably.
That's a thing. Okay. Is bundle. Sure. False. True. I don't know. Whatever. Right. You can do that.
Right.
HD. What else? Add initialization descriptor. This is one thing you don't really see us taking advantage of a lot. Basically, there are some things that are static. Like if somebody created an array of the United States, for the moment and for the foreseeable future, there's 50 of them. There's no need to compute that
right.
at startup time,
right?
Or even ever. You can just have it. You can have it loaded directly into the native heap memory when the application starts up. It doesn't have to be computed. It doesn't have to. There's no array that needs to be alloced and then objects created on the stack and whatever on the heap. I mean,
right.
Like you can just mem copy it directly into memory, right? So Graalvm allows you to do that. You can actually say this thing is going to be initialized at compile time. And that allows for some really interesting optimizations for things like,
static list,
static
right?
data, yeah, or points, right? There's this idea of floating point values and things like that. That can be a lot of that stuff could be just initialized at the beginning. So you can take advantage of this. I don't often have that use case, but you might. Proxy descriptors. So you have add proxy descriptor, new JDK proxy descriptor, right? And
we got a good question while you're adding all these. Pranay asked, what is the advantage of providing hints and annotations code versus providing them via JSON files?
Well, like I said earlier, the types are typed. So you can actually refactor them. If you change a type in your code, the hint will stay the same.
Right.
They'll refactor as well. Because
if you use IntelliJ, it'll pick it up in strings.
Does it?
I don't know. A lot of times. Right.
And also it's clearer. And it's also, you can actually, you get validation, right? Like if you have a string that doesn't match, then there's that. And also it can live next to your code. If you have some code that uses a particular hint, add the annotations and the hints to that right there.
And if we want to write JSON, we'd be JavaScript developers.
Yeah,
right?
and I don't. Okay, so but great question. Either way. Okay, so this is my point is this ability to dynamically create hints is useful. So you can actually say, hey, I want to see if this class exists. I can do things like, I can give it the dotted form of a class and it'll give me a type, right? So A.B.C.
Right.
And that gives me a type, and I can do a kind of reflection. This is not the reflection API because remember, this is at compile time. There is no reflection. There's no runtime at this point. But I have a kind of an API, and I can ask it for the subtypes. I can say, given this interface that I've just resolved, give me all the subtypes. And then I can dynamically compute hints for that. I can say, okay, any instance of this interface is going to be reflected upon.
Right.
I need to support that, right? So if you're us on the Spring team or in Okta and the Spring Boot Okta starter, you know, if you're doing any kind of Okta, or sorry, any kind of starter development or any kind of library support, you're going to want to, you probably have a component model. You probably have certain types that get, you know, you detect the presence of annotations or whatever. You can use this to say, I'm going to find uses of a type with this annotation, or I'm going to find uses of this interface, and then dynamically create the configuration for.
So you're doing a lot more than you can in JSON here.
Way more,
right?
Yeah. Now that's the real reason, right? Is because it's now programmatic. But yeah, you might start with JSON. You might start with those little hints. So okay, this is my very simple example. Do I have what type did I just add? There, I'm going to actually add this, comment that out. Okay, so now I'm going to clean install this, and we'll go ahead and add it to the class path of the other one. Maven install.
Oh, you did it.
No.
Oh.
For the lose. No, it failed. This is your fault.
Because you cleaned it.
Wait, what? It might be. Okay. Oh, I ran the test. Never run the tests. Why do we even have tests for this?
You just gotta delete them. It's one way. Right? Now you're gonna have to clean.
Yeah. See? Okay, so that's installed to COM example. Oh my goodness. This is the other problem. RMRF dot M2 repository COM example. Okay. Go back over here. So now this is the reactive one. We don't need you anymore. Thank you. This is the hints file. We do want that one. Good. So I go back to my build. And again, I'm going to add this to the Aot plugin. So up here, right?
Right there.
There it is. Okay.
So you're not adding it to the Spring Boot Maven plugin. You're doing
No.
AOT, yeah.
AOT, yeah, it's tricky. This part is weird. So what did I call it? Yeah, reusable.
COM example, yeah, reusable. You think IntelliJ already scanned your local repo and knows it's in there? Probably not.
Especially since it deleted everything.
You gotta spell reusable, right?
How dare you? Is this right?
Matt, it's like your Josh's inner developer voice. It's great.
he's the best. All right, so Maven Reload. Let me go over here to my hints and running this hint, whatever. Okay.
Yep.
Maven clean install.
Or you could have just installed once.
I know. Just to get it right the first time, Josh. Okay, I don't want this hint anymore because it's gonna be provided by that external thing. And then what are we gonna do? We're gonna actually load that resource, I guess. So var resource equals new class path resource s dot properties. Gotta avoid tipping off the GraalVM. Try var in equals new equals resource dot get input stream, and then new file, new input stream reader. Is that right? Stream. Okay, and then throws exception. And then file copy utils dot copy to string in system out. Okay, now I don't actually know what sa.properties is. So hopefully it's something useful. So we should see that. Let's just run this and see what we get. Okay. Actually, that could live in a bean.
Oh, it's not found.
No. Why not? That resource. It's not found. Well, okay, we need something quick.
Application resources.
Well, we get those get loaded all. You mean application properties?
Yeah.
Those already get loaded for sure. Like, I just need something. Files. Files. Control. Okay, so what about this? Log carsets. Log for Jdk Spring Boot. Let's see if that works quickly. We're just trying to confirm it'll work on the JDK. Okay, so there's that. So C Spring Boot configuration factory. It's useless. So okay, we'll add this dynamically here. Okay. Maven clean install. Terminal. So we're not going to rebuild it right now because there's no point. I'm just trying to prove that the hints get involved. Running this hint. Right, you can see it being invoked.
Right. Yeah. Yeah.
Oh.
And no pointer.
Oh. What was I doing? Unpack Aot Proxy Hint. Did I leave any hint? That's here, right? I installed it. Let's do that again. And then what about, oh, this? All this is nonsense, of course. Goodbye. Good. Spring Aot generate.
I did.
Did they hear it?
No.
Oh, that's the worst. I just cracked my neck like 5 different ways from Sunday. It's amazing. Okay, good stuff. So now reload, synchronize, reload from disk. Okay, resources. Resource, config. And what was the file called?
Log for J at Spring Boot or something. Log for J2.
Rats. This one. Oh, in the file. Yeah, it's called. There you go. Right, that wouldn't have been added, but for the fact that we added that hint programmatically.
Right.
Okay, so now you kind of have an idea of how to debug real world things. Show us how to debug some real world things.
All right. So let's look at this question here first.
Thank you for that.
Has GraalVM done much to bridge the observability gap between JVM deployed Java apps and native apps?
Observability gap between JVM? No, it made it worse, right? Yeah, GraalVM doesn't love JMX and JVM-TI very much, right?
Right.
Yeah, that's actually horrible. So you're encouraged you'll find Matt's about to just talk about stuff. Let's let him talk, Matt.
So yeah, I did this this blog post a few weeks ago. You can see it's September 16th, so this is a couple weeks ago. And what had happened is Josh and I and a coworker, Brian Demers, I had done some work with Spring Boot and Spring Security to figure out how to, make it work with my company, Okta, right? And so Spring Security has great OAuth support, and I just wanted to set up a resource server and basically be able to, send an access token and access it. And so Josh and I spent all this time figuring out how to basically add these hints like he's talking about and make it work with our Okta Spring Boot starter. So I just wanted to give you, a quick demo of that. But I think one of the most important things is we did like a Twitch stream on this. If you go to the Okta Dev YouTube channel, you can see, the hour and 45 minutes it took us to figure this out. Yeah. And we're talking about builds that, build in like a minute and a half. So we weren't waiting a long time, but in the time that we recorded that Twitch stream, which was in June, we had to add 5 or 6 hints, a couple resource hints and stuff like that. And the time that I published this blog post, we found that all those hints went away.
Yeah.
And so, whether it was Spring or Spring Native or whoever, added them, someone added them, and we no longer needed to add them. So it became, very easy to actually integrate it. And here you can watch the video on this blog post. We had a lot of fun making that thumbnail. And then, it really comes down to this. Yeah, this is all you need to add. So me personally, I think Spring Security's OAuth support should probably have this hint built in natively, right? especially enable HTTPS.
Yeah.
Right. Like HTTP, not so great. HTTPS, pretty great. And so you can see a full example here, right? It's just adding that, and that's basically it. So I've already built the container back here, and all I have to do is run it. And you can see it started up in, port 0.412 seconds. So you might be asking yourself, Josh showed some demos that were like 100 milliseconds. Yeah. Right? Like, why is it taking 400 milliseconds? So as part of our research and figuring this out, what we discovered was Spring Security actually does eager initialization of the issuer. So
JWKS.
Right. And so in, how it works in, what do you call it? OAuth and OIDC is, you go to source main resources here, you can see my issuer, which is right at this URL here.
Secrets.
And if I were to go up to my browser, what OIDC does is they publish this well-known endpoint where you can go open ID configuration. And so that has all the endpoints that Spring Security needs to know about to do, the OAuth dance and, log you in and all that. And so you can see all the information about it. So I think, smartly what they did is, they initialize that as you're starting it up. And so, I was doing some comparisons of, startup time when you're doing a resource server with like Quarkus and Micronaut and Spring Boot. And what we found was Spring Boot was comparable, but this startup, like grabbing that issuer, was actually, slower. And so, I never meant to make like Spring Boot look bad, but it turns out it did. And so nicely enough, the Spring Security team has now added lazy initialization support to their OAuth support. So I don't think it'll be until Spring Boot 2.6, but it should be much faster because it's not doing that issuer request. And what's happening with, Quarkus and Micronaut is they're actually doing it on first request. So, just doing a silly comparison like I am where, we're doing startup times like Spring Boot's, eager initializing and they aren't, and I wasn't doing any performance comparisons of, actually making the first request. So it's cool to see that, just the research we've done this summer has made progress in starting up Spring Boot faster.
Yeah.
So that's one thing. The next thing was, we basically spent a bunch of time. Well, I got to start up that Docker container to show it working, right? I can't just be like, yeah, here it is. Right. So if we were to go to, localhost 8080, redirects me, and then I can sign in and it has, my information in there. So just to show you, the code for this, we'll open it up in VS Code just to make sure my fan's really running good.
It takes a lot longer to open Visual Studio Code than it does to create this, to run this microservice.
But all it is, get this out of the way. I doubt they can see that, but it's just got this, basic simple REST controller and this authentication principal annotation on the OIDC user will allow you to get all the information from the user. So that's a benefit of Spring Security and its OAuth support, right? I didn't really do anything to make that happen. And so that's the whole app. And you'll notice there isn't even any configuration for security or anything. And that's because of Okta Spring Boot Starter. So we add the two components from Spring Security's OAuth. One is to set up a resource server, and the other one is to use what's called Oauth2 Login. So if you hit the endpoint in a browser, it redirects you to log in. If you were to hit the endpoint in a, let's start it up and then show you with HTTP IE, it wouldn't redirect you. It would say, 401, right? So it's very different in that sense. But, we took these learnings and we were like, we should be able to get like JHipster working.
Should.
Right? Yeah. On Spring Native because, we did it with the Okta Spring Boot Starter.
How hard could it be?
And so what we did is we started with this one, Spring Native WebFlux. And so it was basically Josh saying, hey, let's not worry about like databases or worry about anything. Just worry about like getting this thing to start. And so you can see that, we did some turn down logging for basic examples recently, but, the gist of it is, I think just basically in this main class, right, we had to add some hints, right? So if we were to go to the JHipster app here, you can see we had to enable, HTTP and HTTPS. The reason we did both was because Keycloak, which we talk to by default with JHipster, is on HTTP, right? And so that was a simple example there. These were something that you figured out by like things failing, right? So we needed to add those classes of type hints. And then these were another bunch of them that was like, holy cow, I don't know how Josh figured it out, but he did.
So most of these, it's kind of cool because it's like whack-a-mole. It'll just say, hey, I'm broke here. And then you just write the hint. And you
it does tell you, right? And so,
but this one was there's some bit in that traces class where it's actually doing traces.class. It's doing traces.class dot and then some dynamic string.
Right. It's like piecing together that string together, right?
So GraalVM and Spring Native didn't see that, so we had to add that, and that was fine.
Right. So that's one of the first examples. Let's go. We're not going to build any of these. We already pre-built them. So
they take like 10 minutes. These are real substantial applications.
Yeah. Right. And so we have
5 minutes.
This is on the Spring Native examples.
Yeah.
So, there they are. We have this Spring Native WebFlux one. That's the first one we did. And
can we see the Okta one working? By the way,
I already did.
Oh, you did redirect. Yeah. Okay.
Right. So this one is, we just call it JHipster.
Ooh.
Right. And you can see what the heck you're like, what's going on?
Oh,
that's because we don't have Keycloak started, right?
Oh,
so JH Keycloak up is an alias I have to start up Keycloak. And then we can go ahead and try it again. Keycloak's probably still not up. Try it again. You just keep trying.
Yeah.
Just keep trying. It'll eventually be up. And look, now it's up. Right. And so,
not quite.
Well, yeah.
No. It's waiting on something.
Right. And then you're like, kill it. Kill on Control C. It's like trying, but it's like, why not? So maybe this is a problem with native, right? It doesn't allow you to kill them as easily.
Yeah. Well, it's very
there it goes, right?
You can do it,
and then we actually killed it. So now it's started up in 0.372, right?
Yeah.
So still, not too bad. And we're like, okay, well, let's go to our browser and look at that. Localhost 8080. Well, there's nothing there, right? There's actually, we created this without a client. So JHipster, right, is typically used by Java developers to do like a React and an Angular or Vue front end. And we knew that compiling the TypeScript along with the native code was just a disaster, right? We didn't want to wait that long. So these ones have no client when we started creating them. And then we were like, okay, well, let's get into, MVC. So how do we do that with MVC? We went to, well, we didn't even do the MVC one till later, right?
No.
So the next thing we started with was like, okay, let's do something real. Let's make it talk to a database, right? And you'll notice like we never even did the easy thing with security because we want to be the most secure we can with JHipster. And JHipster offers 3 different mechanisms: JWT, which you should never use if you don't have to, because storing stuff in a JWT instead of a session is just not a good idea. You can talk to me about that later if you want. Yeah. But it's like a vehicle that people use to go stateless when they don't even need to go stateless. So, Spring's OAuth support is session-based by default. If you need to scale that, you just use Redis, right? And so we basically never tried JWT. We never tried session-based auth. We just went straight for OAuth, and Spring Security supports that. There's no Okta bits in JHipster for that. It just happens to work with Okta, right? And so we took this Postgres WebFlux, I think was our second one.
Yeah.
Or it was maybe this Angular WebFlux one. And we were like, let's make that work. So let's check out the Angular one.
The Angular one renders a UI, right?
Right.
But no database.
So if we go to target, and then I think there is one.
Okay.
I'm not sure what the difference is between the Postgres one, but look, we're starting in 1100 milliseconds, but that's way better than the 5 or 10 that it usually takes. And if we were to load it up, it redirects to Keycloak there, and we're logging in, right? And then, there's no entities. Oh, this is what we did. So we got the Angular part working, and we never bothered with any entities.
Okay,
right? Because we were like, that requires a database. So let's just check out what hints were needed for that, see if there's anything different. We load this up in VS Code here. And if we were to look at that main Java and this, see if we had any different hints. No, those are all, so we got this one. So these two kind of came in after you logged in. So you'll notice the original one we showed you had these 4 types, and then these 4 types, and then these are like from Micrometer.
Yeah.
Right. And so what happens is after you log in, there's an event that happens, and in Micrometer, stores I'm using these classes. So we had to add those 2 classes, but that was about it once we got a UI going. And then we're like, okay, well, let's get a database going, right? And so that was the Postgres one. So let me clear this and go back here, and then Postgres WebFlux. So the one thing we did do that was very unique for me, and it was mostly Josh being like, I haven't done MVC in a while. I do WebFlux all the time in reactive programming, is that we didn't actually get the MVC bits working till later.
Yeah.
And they turned out to be easier.
Yeah.
Right. And so, but the good news is we figured it out for all of them. So if we were to go to Postgres WebFlux, well, I already created an Okta app here. So you can see that. And if I source that to set my variables, then what I can do is I can actually use Okta instead of Keycloak. So if I go here and I run this Postgres binary that we built, it does a little more, right? And then it's like, what the heck? Oh, we don't have Postgres up, right? So we got to start Postgres. So JH Postgres up. And these Docker containers are built in with JHipster when you generate an app, so you don't have to create them. And then we can just start it up there. And the cool thing is it actually did Liquibase and went through and created the database schema and everything for us and created the tables and all that. And basically, when I entered this week, I just thought Spring Native didn't work with Liquibase. And like all the docs that are out there and the issues in various repositories are other people saying it doesn't work.
Yeah.
And we figured it out like in the last 3 hours.
Today,
right? Yeah, today.
We were like, we don't have to show that. Nobody's expecting it to work, and we were done. We got everything else working.
Right.
And he's like, "You want to try?" I'm like, "Yeah, why not?"
So you'll see it redirects Okta now to log in instead of Keycloak. And so this is really the power of Spring Security, because we didn't change a single line of code within the JHipster app for it to talk to Okta. You could do the same thing with Auth0. You could probably do it with AWS Cognito. It's just a matter of overriding the default properties that point to Keycloak and telling them to point somewhere else. So now we're logged in. That's working. If we were to go to entities,
security authorization server too.
You could probably use that, hopefully on HTTPS.
Yeah. Right? Fingers crossed.
So I could create a new blog here, right, with my handle and my user that just logged in.
Woohoo! So
it's talking to the database, right? It's actually going to Postgres. If we were to look at help, right, that all works. And you can see some of them are failing, but a lot of this is built in to talk to Eureka as a server. And so the discovery client's not working, the reactive discovery clients, that's because we have no Eureka involved in this particular app. And so, that one's all working. Let's look at the code for that. So code up here.
So this one had everything. Like
this one had a lot, right?
A bunch of stuff.
Right.
Web control and services.
So I'll tell you the things that we never were able to get working, but this was probably one of our biggest challenges, because we had to rewrite a lot of the JHipster repositories, and there are 2 DBC repositories that's talking to Postgres, and it was just the way they were done. It was kind of weird. There was interfaces and then inner implementations and stuff like that. So we found we had to rewrite all those. And then this part here was actually, but it was given to us from Spring Native.
Right.
Like every time we would do the build, it would tell us you need to add this Aot proxy hint.
And we don't know why. We still don't know why. This shouldn't be the case.
Right. So
and also that the feature that we hit in Spring Data, that's a supported feature in Spring Data that doesn't quite work. It was a unique, is rare, but it's still a thing that you should be able to do. So those are bugs.
And it works in the JVM, right? If we start the app up and don't have these in there, it works in the JVM. And so we had to add a few more here for Liquibase, right, to get that working. And then we had to add this one down here for the connection pool that Liquibase uses to, create the schema and all that. So, that was all today. Like this morning, we were like, Liquibase doesn't work. And now we're like, yay, it does.
Yeah.
And otherwise, this class was not modified except for, this block of code up here. And then let's show the Spring MVC example. So back to here and clear that. And then, I do want to shut down the Postgres instance because it has a different name for the Spring MVC one, and Docker PS to make sure it's not running. And then go back here and go to Postgres MVC. And then target, called Postgres MVC.
Oh,
so that one took a little while. Again, database not up, right? And one of the things I've noticed with reactive, right, is if your Mongo database isn't up, like it'll still start.
Yeah.
Right. And it'll wait till that connection runs and then it'll connect to it. So that's kind of nice. But we're using MVC here. So we got to do JH Postgres up for my alias there. And just to show you what that alias is, this is OMyZSH plugin for JHipster. You'll see it's just doing Docker Compose and figuring out how to start, that Docker Compose file. And so then we can do target and Postgres MVC here. And that's all started up and working. If we were to log in, it'll go to Keycloak because we didn't set it to use Okta, or still configured for Okta. That's because we're in the same terminal window, right? And I set those environment properties, so we can go here and that's still there. We can delete it, and it's all working. So it was a pleasant experience to get it all working. Obviously, logout doesn't work there, but just ignore that. You didn't see that. And what's there? I'm just curious. Probably some micrometer thing.
Yeah.
Right. It's like a new event here. ID token cannot be found.
Default. Maybe we should add a hint for that.
Right, probably need a hint for that.
That's
so
enough.
right, we'll open this up and
Take it to the
code again, and just show the hints that we had to add for this one.
So we probably should have run the tests. Is what you
Should have run.
Darn it!
Always. All right, and then where are we at? We're at the Java here, and this not this one, but Postgres MVC app. And so this one had less, right? It still made us do it for the resources, which are basically like controllers, right? The REST endpoints, they have REST endpoints in them. So it still prompted us to create those. We didn't have to do them for the repos. And this is just using Spring Data JPA. And then, you know, the rest of these we did have to do. Oh, we had to add these two new ones.
Yeah.
For a specific JHipster dialect that adds a new type for Postgres. And then this was from Hibernate. So we did have to add those two, but that was it. So it was actually less work than the MVC one or the WebFlux one. It just took us a bit to figure out. So what we did is we created this repo out here that we put on our one slide. Let's see where that is.
And by the way, hopefully, you know, we're going to take a lot of this back and feed it back to the respective projects. So hopefully you won't have to deal with this, you know, in a month or two or whatever. But
right.
But in the meantime, it's not so bad if you do have to do it.
Get that out of the way, and then where's my browser? There we go. And so we put it down here in Spring Native examples. And then, so we put this document together, and it's basically, you know, the steps you'll need to do to make a JHipster app work with Spring Native. So you need to add the repositories, right? This is standard stuff. So if you create on start.spring.io, it has all these in there, and you can create a new app with the Spring Native stuff and just copy and paste out of there. Then you need to add, you know, these two properties. DevTools does not work. So if you have DevTools in a project, just comment that out. And then this was probably one of the weirdest ones. So it gave us a note class def found error for WebMVC configurer when we were in a WebFlux project. Yeah. And so you scan the class path, you do dependency tree and all that, and you look for, you know, Spring MVC as a dependency, and it's not there, but we found this Stack Overflow answer, which I think is great. So it totally works. And this person's like, I'm not happy with it, but this is a workaround. Yeah. Right? And it totally works. I did not have to add this web application type reactive, but, you know, I did have to include starter web and then exclude Tomcat. For some reason, that works. Spring Fox is the WebFlux equivalent to Swagger, right? Creates a Swagger UI, and you can see all your REST endpoints and like hit it from a browser.
We could have had to fix that. We didn't have time.
Well, I did get it working at one point, but not in the UI. I just got it working like it could start, right? Okay. So if you go to this issue, there's some hints that you might be able to use. We kind of were like, you know, if the project itself says that we don't work with Spring Native, then we're like, we're out. Yeah, which is kind of why with the liquid-based stuff, we were like, I don't know if we can get that working. They said, you know, they can't, right? So, and then there's this weird one with Netty and this boring SSL static dependency that if we had that in there, it gives us all these weird like errors here. So I think it's used by JHipster's TLS profile if you want to run it with HTTPS enabled, you know, locally. Like if you're on, you know, Google Cloud or you're on Heroku or something like that, you can configure HTTPS up there. And then, of course, you know, just a regular Spring Native dependency. And then these plugins, which are just standard, there's nothing special there. And even this native profile down there, nothing special there. So most of the things that we had to do were not related to, you know, Spring Native, or not related to like workarounds. It was just adding Spring Native. Yeah. The Keycloak YML file by default does expect you to be from localhost. And when you're running the binary, it's not quite the same, right? So we did add 127.0.0.1 there. Spring logback, if you have an XML file and it's in your source main resources and you build a native binary, when you start it, it'll tell you it's not supported. So you delete the file. It's an easy workaround. You know, that might be supported in the future. And then the locale configuration for the WebFlux support in JHipster had this import WebFlux auto configuration, which we don't think it's needed. No. So I think that's a bug in JHipster, but on the WebFlux side, you had to remove that. And then you basically have to add, you know, these hints. And if you're doing an MVC one, you don't need the reactive ones, right? So you can remove these first four from each list. For the liquid-based support, what was that?
Even to see, we thought it wasn't supported. These notes were.
No, it isn't, right?
Yeah.
Like out of the box. So this is from a Spring Native, right? Issued 620 there. And then there's this pull request on liquid-based that's like draft, right? And if you go and look, it's literally just the reflect config and something down here that's like the resources config, I think. Yeah, resource config. And so, we copied those 2 files into our project, and then we had to add some hints here. Right, these load dynamic, these like liquid based ones. Yeah, these 3 right here. And so that was able to get liquid based working, and then we had to add the Aot Proxy Hints, and we had to refactor the repositories, and then Spring MVC Undertow doesn't work. Weird. Right? You have to use Tomcat, and so I think that's a Spring native thing. The web configure had this class 4 name, so this was only used when you're running like with Spring Boot run or in your IDE. So we were like, we're not doing that. Yeah, just cancel it out. And then we had to add these 2 hints, and then you run it like this, and everything works. And so the biggest things we found was Swagger doesn't work, the metrics don't work, and the repositories need some refactoring. So we believe the first 2 issues are likely as Spring Native matures, those will be solved. The last one is probably something we need to fix, within JHipster.
Yeah, and also the feature in Spring Data should be supported. So we in Spring Native, Spring Data, and in JHipster.
Right. So it might be like someone fixes it in JHipster, or Spring Native or Spring Data fixes it and it goes away.
Either way, yeah. Problem. But there's a solution. It wasn't easy. That was the hardest part. Was actually refactoring that code. You had to do some work. If that was software engineering.
And the hardest, that took us, it seemed like hours, but it was probably, only an hour or 2. It was the waiting 10 minutes every time you added one new class to see if that actually worked. And so Josh became so frustrated at one point that he made me not only build it, but do ampersand and run it. Yeah. So I wouldn't be like checking my Twitter while he's waiting for it to start up. Yeah. Right. And so the cool thing was we did all this pair programming this week. Like I flew in Monday, and yesterday
did nothing on Monday.
Right. And then today was all day. Well, we started at midnight and did some stuff. Right.
Yeah.
But that was Tuesday. Right.
Yeah, it was Tuesday stuff.
But the pair programming thing was super helpful because, it kept you from like going and doing something else. Right. Yeah. It just kept your attention on it. So we're able to figure it out and get it all working.
Plus it made it fun. Yeah. This is boring. You remember that XKCD cartoon where they're the swashbuckling on their chairs and the boss is like, what are you doing? It's like code's programming. It's like, oh, okay. Code's compiling, Right. We're back to that kind of. So,
and then he made me do clean every time, right? And so that was like, really, we got to compile the TypeScript again.
Yeah, I know. So sorry,
but we consider the whole thing a success. We learned a lot. We got JHipster working with WebFlux and WebMVC, and there's
been a JHipster issue for like a year almost that you created.
Yeah, so I created it on January 26th of this year, and was like, I'm trying to get this working, and it was crickets, right? Every time someone would chime in and be like, oh, look at it, like they would never come back. And so, basically, if you want to get Spring Native working, just hang out with Josh for a couple of days.
Or hang out with Matt. Like, it was fun. Yeah. We hope you got something out of this. Happy to answer any questions if there are any.
All right. Well, we got one here. Oracle seems to be saving many of the day 2 features of GraalVM for paying enterprise customers. Do you think that would hurt Spring Native adoption?
I don't. So Oracle has done, I don't know, but if they make money, I'm super happy about it. They've been amazing. I cannot believe they're giving this stuff away. Rock on Oracle. The Java 17 is a gold. It's just gold. It's billions of dollars worth of software that they wrote and gave away for free. And then GraalVM is even more incredible, or a different kind of incredible at least. And
yeah, I think they've done a great job. I mean, there's some suspicion that I have that it's like the new Java EE, right? Because they gave EE up, and so they're like, we need the base model that people like, and then we need the thing that they're going to pay for, right? So that's kind of GraalVM Community versus Enterprise Edition. But anything that I've ever done, I mean, we haven't done a whole lot, but the Community Edition works fine, and we haven't need the Enterprise. And I think for companies that need the Enterprise, they're probably happy to pay for it, right?
Yeah,
because things will be faster and better.
On the Mac, what is the minimum requirement for memory? So if you're doing it within a Docker image, then that's doubly expensive, right? Because you've got the Docker desktop, you got the container itself, and you got the RAM required to compile the code in that container. So that's going to be a little bit more than on your Mac proper. Again, I compile GraalVM apps on my Mac M1, my MacBook Pro M1 with 16 gigs of RAM all the time, and it's fine, right? So you can do it with much less.
The one thing we did notice is we had several projects going at once, right? And we'll be building native images for each. And that I wouldn't recommend, because it would actually make it, instead of 5 minutes, it would be 10 minutes for both of them. So there is resource contention when you're doing, just one build on one machine.
Yeah. Yeah, it would like directly. If you had two builds, one build would take twice as long, right? It really, it's like Slack. You will hear your fans begging for help.
And you know what I like? I like that like we have reasons to buy faster machines again.
Yeah,
Right.
like, yeah. Well, isn't this crazy? There's actually a tension there. You have to buy faster machines to develop, but at runtime, your servers can breathe
faster, and the memory usage is way less, right?
Yeah.
Like, so it's like 100 megs instead of 500 or even over like 500. One of the things I noticed with Spring Boot's just built-in Docker support is it doesn't deploy to Heroku with the default build pack because it allocates more than 512 megs of memory, which is what you get with Heroku when you create a brand new app. And so Joe Kutner from Heroku built his own like Heroku Spring Boot build pack, and that only allocates under 500, and then it'll work. So the cool thing is all you have to do is -- builder and pass in a new build pack, and then it'll work on Heroku or something with less memory. But you could also do Spring Boot native, and you'd be at 100, right?
Oh,
you wouldn't even need that 500.
Questions. What is this? Ryzen Threadripper. Yeah, I don't know if you need that just yet. You can play some amazing video games.
You might need
good question. Good question about if you've tried it with a Kotlin boot app from Ted.
Yeah. I do it all the time. I do that, and I love Kotlin.
Right, and Spring Boot has Kotlin support. So there's we call them blueprints that allow you to override the default behavior. So if you want to create a Spring Boot app with Kotlin, you install that. Yeah, you install that as a blueprint, and then you run -- blueprints and point it to Kotlin, and your whole backend will be in Kotlin instead of Java. And the annotations are the same, right? Like there's no difference.
Huh? And then he was asking about memory. Did you see that one? The minimum memory requirement for a native image.
Yeah, you don't need 64 gigs or anything close. We're joking when we say it takes. It's not Slack. It doesn't take that much memory.
It's a long question. Can I ask?
Yeah.
See, we are using the Maven repo for a while, right? If you look into the jars there, like everything is every different version of Java over there. Is there any governing body, anybody taking some take at it to at least a minimum of this version of Java is how these jars should go in here? Otherwise, no. Like I can still see Java 1 jars in there or 1.2 jars in there.
In where?
Maven Central?
Yeah.
Right. They're never going to go away. That's the whole point, is they're always going to be available, right? I think Spring's doing a great job with Spring 6, which is due next winter, right?
Next year, end of the year.
Yeah, sometime. But they're basing it on Java 17. And so they're like, hey, if you want to use Spring 6 or Spring Boot 3, like you got to use Java 17 as a minimum. And I don't know that anyone's done anything as bold as that in the last 10 years, right? Like at one point, maybe they said Java 8, but that thing's been out forever,
Yeah, if you're using Java 8, you're doing it wrong. Get off of, you should be on Java 11 at least. Java 17 is now GA. Come on, people. Do the right thing.
I have Java 17, but I recently built, but I can't use it. The dependency for me using that is tremendous, both on the cloud side and also other stacks related to big data. So it's pretty much impossible for me to use 17 right away.
Well, start slowly with your Spring apps and move on to the other.
Right. We didn't use 17 today, so we
GraalVM doesn't work yet, but Java 11 at least, right? Remember, Java 17 and Java 11 are technically superior in every way. They're faster, more secure, more robust, more performant. They're also morally superior. You will not like the look of despair and disgust in your children's eyes when they see that you're using Java 8 in production.
I love that way you say, Josh, all the time.
Can you use Java modules to like slim out, what you don't want out of the JVM if it's too many, dependencies?
Oh, you get that for free, kind of. Yeah, I mean, with Spring Framework 6, we're going to make it so that it's even more module friendly. But with native images with GraalVM, you get a JRE that's slimmed down. You get a class that's slimmed down by default.
Nice.
And I think if we look at like this Postgres WebFlux one, it's like 200 megs. Which obviously is probably bigger than the jar it would create, but
sure, but you don't have a JRE.
And it only uses like 50 megs of memory or 100 megs or something like that.
That 200 megs is the entire life. That's the entire thing. That you just need a minimal kernel. And that's it. No JRE, no nothing, just that.
And I think you can even like open it and it'll run it like an app.
Yeah.
That's so cool that JHipster, like you got that to work. Aren't you a committer, Matt? JHipster committer?
Oh yeah. Yep.
Yeah, that's what I thought. All right.
Yeah, so we're gonna take all the learnings from this week and hopefully make it so there's either a module for JHipster where you can just run a command and add the support to your JHipster app, or something similar where it's just, you know, good docs and you copy and paste a few things and you're good to go.
I'm a committer in Spring Native, so I'll do the same on the other side. We'll meet in the middle. Hopefully this will just be like no problems at all.
All right.
Is there a good repo for contributors that might want to contribute and get involved in the repos? Like, is there a sometimes I know the Spring team will curate issue lists and stuff. Anything like that people could get engaged in helping with?
Spring Native, maybe?
Well, all the Spring projects have issues in GitHub that are tagged like ideal for contribution or ideal for knowledge.
That was it. The ideal for contribution tag. Cool. Okay.
And
yeah, that's a good way to get involved.
If you find those, just leave a message saying, hey, I'd like to take this, and then somebody on the team will mentor you. We want to help you get started.
Right. And so if we look at the repo here, you can see that, there's not that many open issues, but, good thing we didn't try it on Java 16.
Look at that second.
Oh, yeah, that's you.
That's me. I added it.
Right?
Based on you and me.
Yeah. So, yeah, there's, some things to check for, but, liquid base is in here too, and we figured that out. So, don't be scared just because it says, it's not supported. You can probably figure it out. It just might take a bit.
If we can do it, you could definitely do it.
Right.
Yeah.